Okay, good morning. This is Professor David Delosreyes. Okay, my topic for this session will be college algebra, and I am now, or we are now on lesson number 79. This is college algebra. Okay, let's proceed. The topic for this morning will be continuation of my long video format lecture or discussion, and this is college algebra, lesson number 79. The title of the topic will be Slope of a Line. Okay, let's proceed. We are given point number 1. Okay, capital letter P with the subscript 1. So the coordinates will be x1 and y1. We are given point number 2, meaning capital letter P with the subscript 2. The coordinates of second point is x sub 2 and y sub 2. And the formula on how to take this slope. I will now give you the formula, then we'll try to derive it. The slope in general now, that is under the study of analytic geometry. It will be y1 minus y sub 2 over x1 minus x sub 2. Or this should be equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you use the first one, it's okay. If you use the second one, it's okay. It doesn't matter. The outcome for the slope will still be the same. Okay, let's try to bring out the figure. We will derive this one. If we try to bring out the figure, this should be the y-axis, x-axis, rectangular coordinate system, or the so-called Cartesian coordinate system, right? This is point number 1. The coordinates will be x1, y1. This is point number 2. The coordinates will be x sub 2, y sub 2. Okay. The angle, this angle here is actually angle theta, and that angle theta, this should be the segment. So if we try to draw a horizontal line, there is an angle theta here. Okay, and that is actually equal to the slope. For the meantime, we will just designate that the angle of inclination of the line segment with respect to the horizontal is theta. Okay, so this is theta. Okay, I will try to erase this one. If we try to draw a vertical line and a horizontal line here, this is vertical, this is horizontal, so this should be a 90-degree angle. So to take the slope of the segment, this is the segment, right? You must have to take the ratio of this portion here over this portion, because this portion here is actually, the longer one is x sub 2, this is x sub 1. So the difference of x sub 2 minus x sub 1 is actually x sub 2 minus x sub 1. It is this side here. On the vertical side, this is y sub 2, this is y sub 1. So this side here, this portion here should be y sub 2 minus y sub 1. So this is y sub 2 minus y sub 2 minus y sub 1. This is x sub 2 minus x sub 1. So it seems, excuse me, we are given a right triangle. It's something like this. This will be theta. This is y sub 2, this is minus y sub 1. This is x sub 2 minus x sub 1. This is the line segment, right? And if we try to compute for this angle theta, okay, m is actually equal to tangent of theta. This is by definition. And tangent of theta, okay, this is now trigonometry. It should be opposite side over adjacent side considering angle theta. The opposite side is y sub 2 minus y sub 1. and the adjacent side is actually, considering theta, should be x of 2 minus x of 1. Okay? Oh, actually, that's the formula. So if we try to manipulate this one, so this will come out, it will be something like this. This is y sub 2 minus y sub 1 over x of 2 minus x of 1. Okay, we'll try to manipulate it. We'll write first y sub 1 inside, minus y sub 2, close quantity. And if we try to distribute this one, it should be minus y sub 1. A minus and a minus will be a plus y sub 2. So actually this one here can be written up. We place a negative sign outside. Then we'll write y sub 1 first, then the second. So this one will come out. Right? And on the bottom portion, it's the same. We'll bring out the negative sign. Then we'll write x of 1 first, then minus x of 2. Because a minus x of 2 will be plus x of 2, right? And a minus over a minus, that will now be a plus. So it seems this is gone. Right? So the second equation on how to compute for this slope is actually y sub 1 minus y sub 2 over x of 1 minus x of 2. So either of the two we can use it. It doesn't matter. The resulting outcome for the slope will still be the same. So in general now, for a line segment or a straight line, to compute for the slope under the so-called rectangular or coordinate system, formula number 1, it should be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or the reverse of this, it should be y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So there are two formulas. It's just the difference is that we write the first one ahead of the other one. We could interchange it. Okay, so this is the first formula and this is the second formula. So in general, under the study of analytic geometry, the formula and how to compute for the slope will be these equations here. Next one. For the midpoint of a line segment, if we are given the line segment, right? Am I still on camera? This was p sub 1. This is p sub 2. If we try to compute for the coordinates of the midpoint, okay, P1 is actually with coordinates x1, y1, P2 is with coordinates x2, y2, okay, and we are asked to find for the coordinates of the midpoint. Okay, no need for the derivation of this, because if you try to see the figure, of course the midpoint will be at the 1/2 location. So if you know the abscissa, the abscissa of the midpoint will be x of 1 plus x of 2, midpoint, right? So it will be at 1/2. That's the abscissa of the midpoint. And the ordinate of the midpoint, okay, we'll take the sum of the ordinates, y1 plus y2 over 2. So this is the abscissa of the midpoint, and this is the ordinate of the midpoint. So in general now, under the study of analytic geometry, if we are considering a line segment, the coordinates of the location of the midpoint should be at the coordinates x1 plus x2 over 2, and the ordinate will be y1 plus y sub 2 over 2. Okay, that's for the midpoint. Okay, let's try to take two special cases. Under the study of analytic geometry, it's a must that we should know what's the slope of a horizontal line and the slope of a vertical line. Okay, under the study of analytic geometry in general, this is the formula and how to compute for, or this is the value of the slope of a horizontal line. The slope of a horizontal line, okay, will be 0. And the slope of a vertical line, which is designated by M, If we are considering vertical line, this slope is actually undefined. It will not exist. Okay? So how could we prove that the slope of the horizontal line is 0 or the slope of a vertical line is undefined? It's easy. If we try to draw a horizontal line, if this is point number 1 and this is point number 2, the coordinates of this is x1, y1. The coordinates of point number 2 will be x2, y2. If we try to compute the slope of this, okay, we'll just use the formula. Slope is actually, in general, it is this formula, right? It's the difference y1 minus y2 over x1 minus x2. Okay, let's try to compute. What is y1 here? Y1 is this height, right? So it will be y1, okay? This is y1. What's the value of y2? Y2 is still equal to y1, right? If this is y1, this is y2, so meaning to say they are equal, right? So we will be subtracting y1. Since y1 is equal to y2, this is minus y1 again, right? If the line is horizontal, right? And how about x? X1 is this one. It is to the left. So this is x1. And what's the value of x2? This is x2. Minus x2. Okay? We use this formula. For a horizontal line, y1 is actually equal to y2. So actually the difference of y1, we'll just place y sub 2. Then think about it. This is y1, this is y2, they are equal. So the difference y1 minus y2 should be equal to 0. So what will come out? It will now be equal to 0 over, for the abscissa, they are not 0. It will be an x1 minus x2. And for any line segment, x1 is actually a real number, x2 is a real number, so actually the difference of this will be just still be a number, right? And this will be 0 over a number. And what is a 0 over a number? It will be equal to 0. So for a horizontal line, this slope is 0. Okay, that's the proof. It's the. Okay, let's go with the vertical line. For the vertical line, it's the same. This is the vertical line. This is point number 2. This is point number 1. Okay, again by using the slope formula. It is y1 minus y sub 2 over x1 minus x sub 2. Where is y1? Y1 is this height here, right? So there is a value of y1 for a vertical line, y1. Where is y2? Y sub 2 is this one. So there is a value for a vertical line, there is a value for y sub 2. How about the value of x? The value of x1 is this one, right? This. Minus x, and this is x1. Minus. What's the value of x sub 2? It is this value here. This is minus x sub 2. If you try to look at it, the value of x1 and the value of x2 are actually the same. So if we try to take the difference of this, it will be equal to y1 minus y sub 2. They're equal, right? So this will be 0. And the difference of y1 minus y2 will still be a number divided by 0. And a number divided by 0 is actually undefined. Undefined. It will not exist. So for a vertical line, I place it here, the slope is actually undefined. Okay, that's the proof. Okay, that's it, guys. These are the things that are needed under what they call this college algebra lesson number 9, slope of a line. So I brought out the formula and how to compute for the slope. There are two formulas. They are the same. And for special cases, for the midpoint of a line segment, it will be the location of the coordinates of the midpoint will be at the 1/2 of the sum of the abscissas and 1/2 of the sum of the ordinates. That's for the midpoint. And another special case, okay, under the study of analytic geometry, okay, if we say horizontal line, you should know immediately that the slope will be 0. Okay? And another special case, if the line is a vertical line, the slope is undefined. Okay, that's it, guys. Okay, good morning from Los Angeles. This is Professor David J. Reyes.